Every year, billions of bullets are fired around the world on shooting ranges, in military operations, and even in Olympic competitions. But have you ever stopped to wonder what it actually takes to make a bullet? This tiny piece of metal might only weigh a few grams, but behind it is a world of molten lead, precision engineering, and high-stakes quality control, where a single mistake could make it completely useless or even dangerous. Before we dive in, I want to know in the comments, have you ever held a bullet in your hand? I'm curious how many of you have seen one up close. Before bullets became the precise rounds we know today, soldiers used musket balls, small lead spheres, which had to be hand-loaded with loose powder, slow, messy, and inaccurate. Everything changed in the mid-1800s, when the first self-contained metallic cartridges were developed. These combined the bullet, casing, powder, and primer into one neat package. For the first time, soldiers could fire multiple shots without fiddling with loose gunpowder. Here's a fun fact. The French Le Faucheux cartridge of 1836 is considered one of the first practical metallic cartridges. Let's talk about the bullet anatomy. Pick up a modern round of ammunition and it looks simple, but you're actually holding a tiny system of 4 parts. 1. The bullet, the part that leaves the gun. 2. The casing, the container that holds everything. 3. The gunpowder, the explosive fuel. 4. The primer, the spark that starts it all. Most people don't realize this. Every single component has to be engineered with microscopic precision. Step 1. Making the bullet. Imagine stepping into a modern ammunition factory. The air carries a faint metallic tang, and rows of machines hum in a carefully synchronized rhythm. This is where the bullet, the part that actually leaves the barrel, is born. The process starts with lead, still the heart of most bullets today. Ingots of solid lead are fed into furnaces, melting into shimmering silver pools at over 327 degrees Celsius, 620 degrees Fahrenheit. From there, the molten lead is either cast into molds to form tiny, perfectly sized cores, or extruded into long, thin lead wire, which is then sliced into tiny cylinders called slugs. This is where the magic of precision comes in. Every slug must be exactly the same weight, down to fractions of a gram, because even a tiny inconsistency can throw off accuracy. High-speed automated scales constantly monitor the slugs, kicking out any that are overweight or underweight. Next comes the copper jacket, the golden shell that wraps the soft lead core. Why copper? Because it's smooth, strong, and protects the barrel from lead fouling while allowing the bullet to slice through air at supersonic speeds. Sheets of copper are fed into massive stamping presses. Imagine a machine punching hundreds of tiny cups out of a shining copper plate every minute. These cups are then drawn into elongated shapes, stretched multiple times through precise dies until they become the bullet jackets we recognize. Then comes assembly. Each lead core is inserted into a copper jacket using a process called swaging, basically pressing the core into the jacket under immense pressure to ensure a tight, uniform fit. This gives the bullet its final shape: round nose, hollow point, or Spitzer for long-range rifles. Some bullets receive additional finishing. Polishing in rotary drums filled with crushed walnut shells to achieve that flawless shine. Lubrication or coating to improve feeding in firearms and reduce wear. But a bullet alone won't do much. To become a complete round of ammunition, it needs a home. And that's where the brass casing comes in. Do you know? A single automated line can produce over 200 bullets per minute, or nearly 12,000 bullets per hour, and some military factories can churn out over 100 million bullets per year. Step 2. Crafting the brass casing. Now that we have a bullet, it needs a home, a strong shell to contain the explosion that will send it flying. That home is the brass casing. The journey of a brass casing starts with flat sheets of gleaming brass, which is an alloy of copper and zinc. These sheets are fed into high-speed presses that punch out small cups, almost like tiny golden bottle caps. Then begins a process called deep drawing, where those cups are stretched into longer and longer cylinders. The casing passes through multiple dies, each one pulling it a little further until it reaches the perfect length and diameter. To prevent the metal from becoming brittle, the casings go through annealing, a heat treatment that makes them both strong and flexible. Without this step, the case might crack under the violent pressure of firing. Finally, the casings are tumbled in giant polishing drums, emerging shiny and golden, like tiny brass trophies. Step 3. Adding the primer. The primer is a tiny component, but it's the heart of the bullet's ignition system. Without it, the powder won't ignite, and the bullet becomes nothing more than a piece of metal. Primers are tiny metal cups filled with shock-sensitive explosive compounds, often lead styphnate or modern lead-free alternatives. Even the smallest impact or static spark can trigger an explosion. In the factory, robotic arms delicately handle primers to minimize risk. In older factories, this step was done by hand, and workers had to wear anti-static clothing and avoid any jewelry. Once the chemical mix is loaded into the tiny cup, the primer is carefully pressed into the base of the brass casing. From here on, this round has a pulse. If you dropped it hard enough, it could theoretically ignite the powder when struck in the right spot. Do you know? In World War II, primer production was so sensitive that factories would sometimes experience chain reaction explosions from static electricity. Modern safety measures have made this extremely rare today. Step 4. Loading the powder and final assembly. Now comes the explosive soul of the bullet, the gunpowder, also called propellant. Each casing passes through automated powder loading stations, where a precise charge is dispensed. This powder is measured down to fractions of a gram, because accuracy is life in ammunition manufacturing. Once the powder is in, the bullet, the copper and lead projectile you saw earlier, is seated into the casing. This is done by a high-speed pressing and crimping machine that locks the bullet in place. Crimping ensures the bullet doesn't shift during transport, recoil, or loading. Some specialty ammunition gets sealant applied to the primer and bullet edges to make the round waterproof and battle-ready. Military-grade rounds often go through this step. But before these rounds can leave the factory, they need to survive the most intense test yet: quality control. No bullet leaves the factory without earning its badge of safety. Quality control is the final and most unforgiving step. First, visual scanners and laser systems check for dents, cracks, or deformations in the casing. Even a microscopic crack can make a bullet dangerous. Then, X-ray machines and weight sensors ensure that each bullet has the correct powder load and that the bullet is perfectly seated. From every batch, sample rounds are sent to indoor ballistic ranges. Here, they're fired into test chambers that record muzzle velocity, how fast the bullet travels; chamber pressure, how much force is generated; accuracy and grouping. Does it fly straight? If a batch fails these tests, it's scrapped or recycled. No second chances. The 9mm round holds the title as the most widely produced caliber in the world, with billions manufactured every year for both civilian and military use. In fact, some ammunition factories are capable of producing over 10 million rounds in a single month, running around the clock to meet global demand. What might surprise you is that properly stored bullets can remain usable for decades without losing much of their performance. Collectors and militaries often store ammunition in climate-controlled environments for long-term readiness. Next time you see a bullet in a movie or a display case, remember the journey it took: molten metal, precision chemistry, and relentless quality control. Tell me in the comments, what surprised you most about how bullets are made? If you enjoy hidden stories behind everyday things, hit subscribe. You won't want to miss our next factory deep dive.